Hello, good day, grade 12. So, welcome to our first video lesson for General Physics 1, which is measurements. So, the learning competencies to be discussed for this lecture are the following. But before we start, may I ask you, in terms of your own words, how do you define physics? For me, I do agree with Albert Einstein. Everything happens for a reason, and the reason is usually physics. So, how do we say that uh, this is my definition of physics? Because scientifically, it is the science of matter, its motion, as well as space and time. Physics can be taught of a humanity's attempts to describe and explain our universe. Okay? So, physics is a very broad subject that even the smallest particle of our universe we are studying under physics. So physics has two branches. So we have mechanics and dynamics. Under mechanics, we have statics and kinematics. On the other hand, under dynamics, we have waves, light, heat, electrical, mechanical energy, as well as nuclear physics. So based from the stems of each branches of physics, how do you differentiate mechanics and dynamics? Okay? So, to summarize, based from its stem, we can conclude that mechanics is deals with the objects or bodies that are visible by the naked eye. So it is somewhat called as macro physics, while on the other hand, dynamics deals with something or bodies that can be felt. Okay? Or in other terms, it is called as micro physics. Okay? But on this lecture or on this quarter, especially on General Physics 1, we will be focusing more on mechanics. So the macro physics, the study of statics and kinematics. So since we have stated before, okay, on our previous slides, that even though the smallest particle of the universe as well as the biggest unit in the universe, we are explaining it through our study in physics. Okay? In order for us to measure those quantities, we use units. Okay? On the next part of this discussion, may I ask you to tell me what is the specific units we use per each quantity. So let's start off with speed. Okay, for speed, we use meters per second. Second, how about acceleration? Okay, the unit used for acceleration is meters per second squared. And then force, okay, so it is measured, okay, in terms of Newton or capital letter N in some terms. Okay, it is derived from the unit kilogram multiplied by meters per second squared. Okay, and then last, we have work. Work is equals to joule, okay, capital letter J, or Newton meter. We can also use the unit for work, which is kilogram multiplied by meter squared over second squared. Okay, so those units were classified according to different kinds of physical quantities. So we have here 7 basic classification of physical quantities, namely length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Okay? So the base unit for this 7 major physical quantity are meter for length, mass for kilogram, time per second. Okay? So we use ampere for electric current, Kelvin for temperature, mole for the amount of substance, and then candela for the luminous intensity. Okay? So, but we would be seeing more of the length, mass, and time for statics and kinematics. Okay? So, even though we have base units and 7 major physical quantities, okay, there are different unit systems in different part of the world. Okay, so we have two major unit system, and they are the SI units of system, okay, which is also known as the International Unit of Systems, okay, otherwise known as metric system. So ito yung ginagamit natin, international system of units. On the other hand, we also have a different um, kind of unit system which is used on the nations ruled by the British Empire. So this is used on countries such as United Kingdom, London, okay, and such. So this is called as English units or the imperial system, okay. So this units of system or classifications of units of systems is just like languages. Okay, so for example, you have a friend which is a Korean national and you have another friend which is a Filipino. Okay, so how do your two friends from different countries would communicate to one another? So we have to translate the language. Okay, so just like units of system, we have two classes of units of a system, the SI and the imperial. Okay, so paano natin gagawin ng paraan na magkakaintindihan yung dalawang units of system natin? So, paano tayo magkakaroon ng isang single mathematical language? So, if we are talking about literary language, we translate. Okay? If we are talking about mathematical language, we convert. Okay? So, paano tayo magka-convert? We use conversion factors. Okay? Presented on your screen are the list of the conversion factors we are going to use. But take note, it seems that it is blurry, but I will be posting a different one on your class stream. Okay? So, to work on this, you may pause this video if you want to try answering this problem. So use the conversion factors from the previous slide in answering this question. Okay? So using appropriate conversion factors, find first the speed in meters per second equivalent in 55 miles per hour, and then B, the volume in cubic centimeter of a tank that holds 16 gallons of gasoline. Okay, so let us try answering this problem. So let's start with the first unknown, letter A. So we are going to find the speed in meters per second, which is equivalent to 55 meters or miles rather per hour. So we have to first know the conversion factor of miles per meter. How many miles does 1 meter have? Okay, so according to the conversion factor from the previous slides, 1 mile is equal to 1,600, approximately 1,609 meters. Okay, so another thing is we have to convert minutes or hour rather to second. Okay, so 1 hour is equals to, okay, how many minutes, okay, in 1 hour? So 1 hour is equals to 3,600 seconds. Okay, so we have to calculate speed given, okay, 55 miles per hour. Okay, we have to convert it to meters per second. Okay, so the technique I use here is I do the cancellation method. Okay, so titingnan mo kung yung unit mo. Okay, kung ang nasa taas ay mile, so supposedly, para makancel mo yung mile sa taas, you have to put mile dun sa baba nung imumultiply mo sa kanya. Okay, so sabi natin, ang isang mile ay equal daw sa 1,609 meters. Okay, so na-cancel na natin to. Let's change colors para makita nyo. So, canceled na yan. And then, next ay yung hour. So, kailangan ma-cancel natin yung hour. So, 1 hour, according to our conversion factor, is equals to 3,600 seconds. Okay, once na-cancel na natin yung nandun sa original nating units, okay, units of measurement. So, pwede na natin tong i-input sa calculator natin, 55 times 1609 meters times 1 over, okay, so wala naman, 1 times 3,600 is 3,600 seconds. Okay, so the speed in meters per second is equal to 55 times 1,609 divided by 3,600 second. Okay, it's also equal to 24.5819 meters per second. Okay, so that is for question A. How about question B? So, we have to convert the volume in cubic centimeter of a tank that holds 16 gallons of gasoline. Okay, so we have to first find the conversion factor of gallons to cubic meter. So, since ang hinahanap naman natin is for gasoline. So, gasoline is a kind of fluid. Okay, so 1 fluid gallon, okay, is approximately equal to 231 cubic inch. Ma'am, bakit po inch po yung nilagay nyo? Kasi gallon, okay, sa imperial system yan. So, kailangan, pag i-convert mo siya, kailangan imperial din yung gagamitin mo. And each inch is yung based unit kapag ka naka-imperial system ka. Okay? So, and then saka pa, base unit to based unit ng other units of system, which is in meters. Okay? So, that's why hindi natin siya diniretsyong 1 fluid gallon to centimeter. Okay? So, and then, saka pa natin i-convert yung 1 inch to centimeter, which is equals to 2.54 centimeters. Okay? So, volume, we have to do again cancellation method. So, 16 gallons, yung given natin, multiply, okay, kailangan nasa baba yung 1 FL gal, or 1 fluid gallon, multiply by 231 cubic inch. So, kailangan nasa baba yung inch natin. So, 1 inch. Since volume po ang tinutukoy natin, sa volume, cubic factor, so we have to, okay, raise this term into 3. Okay? So, para ma-cancel po natin na ang matatanggal po natin sa part na to is the volumetric function. Okay? So, and then, sa base naman natin, 2.54 cm. Okay? So, cancel natin yung cubic inch. So, kapag sinimplify nyo na to, cubic inch, and then 1 raised to 3 naman is also equal to 1. So, doesn't matter. And then, okay, since na-cancel na natin yan, so 16 times 231, okay, times 2.54 inch, centimeter, this should be centimeter cube over, since wala naman 1. Okay, so the volume or the equivalent volume of 16 gallons to cubic centimeter is equals to 16 times 231 times 2.54 cube is equals to 60,566.5885 cubic centimeter. So, kung mapapansin nyo, yan, ang dami, diba, ang numbers, daming numbers nakalagay, so medyo nakakatamad siyang sulatin, in all honesty. Okay? So, pwedeng gawin dito is, i-convert nyo siya into this kind of expression. 6.1 times 10 raised to 4 cubic centimeter. So, anong tawag dito sa technique na to? So, this is called as converting or expressing your answer in scientific notation. So, ano ba ang ibig sabihin ng scientific notation? Okay? So, let's go into deeper understanding of the topic. So, for example, paano nyo i-compare ang measurements ng Earth, okay, in comparison to an atom? Okay, di ba? Parang, ma'am, sobrang laki po ng difference nila. Okay, how do you say so? Siyempre, yung Earth is a celestial body and atom is a microscopic material. Okay? So, we are going to compare that. Okay? So, the mass of the Earth is equals to this value. Okay? So, 5, 9, 72, and then 0. Okay? And then, the size of an atom is equals to this value. 0.1. Okay? So, kung i-imagine ninyo, diba? Parang, hindi nyo naman, okay, sasabihin talaga na, ma'am, 5 trillion, ma'am, hindi ko na po alam. Kasi ang daming zero, diba? As well as this one. Ma'am, ang dami pong zero, hindi ko na po alam kung ano po yung value niya. Okay? So, para mas mapadali yung expression natin of these quantities, we use scientific notations and engineering functions. Okay? So, scientific notations is used if our quantity is too small, just like the size of an atom, and then if our quantity is too big, okay, mass of an Earth. Okay? So, minimum nito, kunwari kapag ka 1,000, pwede mo na siyang i-convert as scientific notation. So, 4 na digits na yon. So, kapag ka naman sa too small, milli, 0.001, basta naka-4 na digits ka dun sa quantity mo. So, you can express that in terms of either scientific notations and engineering functions. So, later on, malalaman pa natin ano ba ang pinagkaiba nitong dalawa. Okay? So, scientific notation is a way of writing any number between 1 and 0 multiplied by an appropriate power of 10 notations. It is a shorthand method of writing numbers that are very large or very small. Okay? So, for expressing quantities on scientific notation and engineering function, we use this table. Okay? So, hindi ko na siya babanggitin. You may take a screenshot of this table. Okay? And then, try to memorize this one. Okay? So, ito yung values niya. And ito yung corresponding engineering function niya. Okay? So, itong 10 times raised or 10 raised to 18, this is for the scientific notation. Okay? So, yung exa naman, peta, and so on. So, yun yung engineering function. Okay? So, mas maintindihan nyo siya pag nagamit nyo na siya into action. So, this one, the first one is for larger values. The second table is for smaller values. So, ano ba yung mga based unit natin or yung 10 raised to 0, which is equals to 1. So, ito yung naka-meters, gram, okay? So, yun po yung mga, kung ano yung based unit ng ating major quantities. Okay? So, balikan po natin itong ating Earth and atom. Okay? So, mapapansin natin, nabilang nyo ba kung ilang zero yung meron yung mass of Earth how about yung size of atom? Okay? So, i-try nating i-convert sila using scientific notation. So, let's start with the mass of the Earth. Okay? Ang una yung technique na gagawin is to locate where is the decimal point. Okay? In this case, the decimal point is here. So, ang goal natin, 'di ba, is mapaunti yung values or mapaunti yung zeros or numbers or digits na nandun sa quantity na yon. So, we have to eliminate, okay? Eliminate the digits. So, kapag ka ang place value mo or sorry, decimal point mo is at the end of the digit and you want to eliminate zeros from the left part. Okay? So, kunwari ito yung point value mo, tapos gusto mo, nandito yung decimal point mo. So, eliminate mo yung part na to, which is towards to the left. Okay? Papunta sa left. So, ang gagawin mo, i-move mo yung decimal point mo papunta sa left. So, bibilangin mo kung ilang beses ka nag-move. Okay, ulitin natin. So, para sabay-sabay tayo magbilang. So, bibilangin nyo kung ilang beses kayo nag-move ng decimal point. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, then 22. Kung tama ba? Okay? So, nag-move tayo ng 22 points. Tama ba ako? Wait. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and then 22. Okay, so tama nga, 22. So, 5.97 to, okay, so tanggalin na natin yung 0 kasi hindi na naman siya mahalaga, times 10 raised to 22 kilograms. Okay? Okay, so the scientific notation for the mass of Earth is equal to 5.97 2 times 10 raised to positive 22 kilograms. So, ma'am, bakit po positive? Okay, so we have a rule na kapag nag-move ka, okay, papunta sa left, okay, positive yung magiging scientific notation mo. Okay, so, katulad nito, yan. Okay, so we have here a small number. Tapos, nakita nyo, yung decimal point nyo nandito. So, in order for us to okay, so this should be on the last part pala. Okay, 1. Yan. Sorry. Okay, so we have to move here the decimal points papunta dito. Yan. So, para maging whole number na lang yung ating given. Okay? So, kung bibilangin ulit natin yan, so that is 1 times 10 raised to, okay, we do 10 steps. Okay, so 10 jumps. So, negative 10 meters. Okay, so this is the scientific notation for the size of an atom. So, how about the engineering function of that scientific notation? So, we have discussed where we have found that the scientific notation for the mass of Earth, Okay? Is equals to 5.972 times 10 raised to 24. Okay? So, madali nating mako-convert yon from our previous given using the um, quantity ladder. So, pwede, if nag-step down siya, so, negative yon. If nag-step up siya, okay, positive yon. But, for me, I personally use the left and right. Okay, depende sa position ng decimal point. Okay, so, now, convert na natin siya into engineering function. Okay, since dito, ang given natin is 10 raised to 22. And ang value lang na pinakamataas dun sa table natin is 10 times or raised to 18. Okay? So, we have to express that into 10 raised to 18. Okay? So, nag-move ako ng mga ng decimal point. Okay? So, nung nag-move ako, ito na yung equivalent ni. Okay, so this should be 4. Yeah. Okay, so this should be the values, okay, the equivalent of 10 raised to 22 to 10 raised to 18. So, since engineering function na yung pinag-uusapan natin dito sa part na to. Okay, so pwede nating tanggalin na yung 10 raised to 18 at palit na lang yung symbol na e. Okay, because the symbol e corresponds that the value should be multiplied by 10 with the power of 18. Okay, so equal siya sa 59,720 kilogram. So, same as the size of an atom. Okay, so we know that it is 10 raised to negative 10. So, 1 times 10 raised to negative 10. So, we have to move another decimal point in order for us to get 10 times 9 or 10 times 1 times 10 raised to negative 9. Okay, so kasi yun yung nasa table natin, yun yung pinakamalapit. So, so 10, yung 10 times, yung 10 raised to negative 9 should be changed into nano. Okay, nanos. This is all small letters ha. Okay, so this is all small letters. So, M or 10 nanometers. Okay, so yun yung equivalent ng 1 times 10 raised to negative 10 meters. In engineering function, we express it as 10 nanometer. Okay? So, the next is the significant figures. So, significant figures is helpful for us because it is the digits in a number or measurement that are not being used and considered as place values. For example, katulad nung kanina, yung earth and yung atom, sobrang daming zeros. Okay? Zeros are not significant if they are used to indicate the position of the decimal point. Okay, so how do we compute or how do we analyze the value or how many significant figures in a given quantity? Okay, so meron tayong 6 na rule. So yung first, lahat ng non-zero figures are significant. Okay, so for this example. Next, if our zeros are in the middle of 2 or in the middle of our non-zero number, if the zeros is sandwiched by a non-zero number, we compute or we include them in our counting of significant figures. Okay? So, 5.008, sandwich po yung ating dalawang zero. So, the number of significant figures would be 4. Okay, next is this one. Putting scientific notations into work. Third rule, zeros after the decimal point is significant. Okay, so we have here our example for 43.0 and then meron tayong tatlong zero after the decimal point. It is included in our counting, so total of 5 sig figs. And then fourth rule, if our zeros and coefficients in scientific notations are significant. Okay, so we have to disregard the times 10 raised to negative 3 and then focus on our value here. Even though naka-scientific notation siya, okay, yung zero niya ay calculated pa din. So, 2 sig figs. And then next, number 5, leading or beginning zeros are not significant. So, if we have a zero, we have zeros before a non-zero quantity, so it is not significant. So, for this example, isa lang yung sig fig natin. And then last, zeros in a large number without a decimal is not significant. Okay, so 4,000, wala tayong decimal point, 1 sig fig lang. What if naglagay tayo dito ng decimal point? Okay, ilan na yung sig figs natin? So, ang sig figs natin magiging 4 kasi meron na tayong decimal point. Pero dahil wala, okay, so isa lang yung i-consider natin. Okay, so that is for scientific notation. Okay, next is accuracy and precision. So the difference between these two is that the accuracy tells us how close a measurement is the correct value for that specific measurement, and precision is how frequent, okay, that value is repeated on something for your results, and the measurements refer how they are close to one another. Okay, so to further discuss on the difference between accuracy and precision, let's take a look at this target. Okay, so dartboard. Yan. So makikita natin ano kaya yung dito sa una nating figure, ikalawang figure, ikatlong figure, as well as ikatlong figure. Okay? So sa unang figure, it is accurate and precise. Okay? Bakit po accurate and precise? Kasi makikita nyo, ang goal natin dito is to hit the bullseye. So lahat ng points natin nasa bullseye, and then lahat ng values naman or lahat ng na-hit mong point ay magkakadikit. Okay? Next po is not accurate but precise. Okay? Unlike this one, hindi mo man na-hit yung bullseye, pero magkakadikit pa rin yung points mo. Okay? So, it is considered as precise. Next, this is accurate but not precise. All of them are close to our target, pero yung lahat ng points mo, okay, hindi naman magkakadikit sa isa't isa. That's why it is considered as not precise. And then lastly, it is not accurate and not precise. It is far from our bullseye and the points are far away from one another. Okay? So, sorry, this is not supposed to be in here. Okay, so what went wrong? Okay, so this is a total failure. But I'm talking about this one. Okay, so how do measurement, okay, it's very essential in engineering, architecture, and technology. Okay, sa tingin nyo na nagkamali dito? Yan, di ba parang talaga nagkamali mga engineer, architect, lahat na nagkamali dito sa part na to. Okay, ba't hindi nagdugtong yung tulay? Okay, so meron tayong mga, syempre, hindi naman maiiwasan. Meron tayong mga nami-meet na errors, especially in measurement. So, we have two kinds of errors. Okay, so we have the random error as well as systematic error. The difference between these two is that systematic error occurs as a result of a flaw in the experimental design or apparatus. For example, okay, magsusukat ka ng isang lote. Ang ginamit po ay ruler. Okay? So, that is an example of systematic error. Kasi, supposedly, dapat meter, okay? Meter yung gagamitin mo, yung construction meter yung gagamitin mo. Pero yung ginamit mo is rulers, 12-inch lang. So, magkakaroon ka talaga ng systematic error. Second, is yung sa random error. Sa random error caused by unpredictable changes in the experiment. Okay, for example, you are experimenting the growth of a plant. Okay, so yun yung nasa thesis mo. And then, something happened with the plant, hindi mo siya napaarawan or nagkaroon ng bagyo, nadanggel siya nung kaklase mo. That's considered as random error. Kasi hindi mo naman in-expect na ganun yung mangyayari dun sa variable mo. Okay? So, we also have absolute error, relative error, and percentage error. Okay? So, absolute error is a difference between the actual and measured value. Okay? Whenever we are experimenting on something, meron tayong basis. Okay? For example, meron tayong control. Okay? May control value tayo. So, yun, dun tayo, okay, dun tayo nagde-differentiate para makakaroon tayo ng conclusion. So, if yung control value mo or yung perfect, okay, perfect variable mo, okay, kinuha mo yung difference niya with your independent variable, okay, so yung error, okay, na mapuproduce mo dun sa difference ng control and independent mo is called as absolute error. And then, yung relative error naman is the value of your absolute error divided by the actual measurement. Okay, so this is more of the statistics part. Okay, so the percentage error is just simply the percentage of your relative error. So kasi yung relative error mo sa the simple quantity, naka-decimal places. So yung percentage ng quantity na yun is your percentage error. Okay? So, that would be all for this lecture. After watching this video lesson, if you have questions, do not hesitate to message me through my email or my messenger. Okay? So, and then after you have reviewed this lesson, go to our classwork, click for this activity from your work tab, create a Google Docs or a PDF, and then answer your activity sheets. Make sure to review all the instructions. Okay, so that would be all for this day. So I hope you had a great day ahead of you. Stay safe, stay sanitized, and stay hydrated. So sana masarap ang ulam nyo lagi. Grade 12. Goodbye and thank you.